Hey developers, what if I told you that you could potentially build a fully functional marketplace using Bitcoin security, but with all of the flexibility of Ethereum smart contracts? That would be so cool, right? So in the next 15 minutes, I'm going to show you exactly how to build this Bitcoin-backed marketplace from scratch. And trust me, by the end of this video, you will be able to deploy your own version of this project. So without wasting any further time, let's get started. So here's the thing. The Bitcoin is incredibly secure, but when it's come to smart contract development, it is limited. However, Ethereum, on the other hand, has amazing smart contract capabilities, but it's expensive and sometimes very slow. So here comes Rootstock. It's basically a bridge that gives you best of both of the worlds. Here comes Rootstock. It's basically a bridge. Rootstock is a Bitcoin sidechain that is EVM compatible. What does that mean? Well, you can run your Solidity smart contracts exactly as they are. You just don't need to make any changes to it. But here's the twist. They are backed by Bitcoin security through something called merge minting. That's a too cool concept, right? And the best part is there's two-way peg system. You lock your Bitcoin, get RBTC, the Rootstock Bitcoin in return, use it in the smart contracts, and when you are done, you can convert it back into the Bitcoin. That's 1-to-1 ratio as always. Plus, you can get 30-second block times and much lower gas fees than Ethereum mainnet. It's like getting Bitcoin's trust with Ethereum's power. Now, let's move forward with the architecture of our app that we are going to make. Our marketplace has 4 main components. First, you have got your Next.js frontend. This is where users see and interact with. Nothing fancy here, just good old React with some magic of Web3, right? Secondly, there's the Web3 integration layer. This is where our integration part will live, like ethers.js handling all the communication between frontend and the smart contracts. That all will be integrated into this layer. Thirdly, your Solidity smart contracts. This is where it gets very interesting. These run on Rootstock virtual machine, which is basically the Ethereum virtual machine, but optimized for Bitcoin ecosystem. And last but not the least, the Rootstock network itself. This is where your transactions actually get processed, secured by Bitcoin miners through merge minting. For this tutorial, we are going to use the testnet of the Rootstock blockchain. Okay, so here's the final flow. User locks its Bitcoin, thereafter receives RBTC and interacts with your marketplace smart contract, and transaction get processed on the Rootstock testnet, and everything is secured by Bitcoin's hash power. It's elegant, cool, and calming. All right. Now, finally, let's build this thing. I'm going to walk you through each step, and don't worry, I'll keep it simple. Okay, so let's just go over to remix.ethereum.org, and here we will create a new workspace. We'll just choose a blank workspace. I'll just name it as RBTC Marketplace. Yeah, pretty good. And now what we need to do is we need to create a file named marketplace.sol. It's the contract that we'll be building. So guys, this is the marketplace.sol contract that we need. Here we'll go through line by line so that you can understand what the code does and also why it's written this way. So let's just go ahead. In the very first line, it specifies the license of the code MIT. That is the open source code. Then we declare the Solidity compiler version, that is 0.8.19 and above version, meaning any compiler from 0.8.19 up to but not including 0.9.0. Okay, Solidity 0.8 plus comes with automatic overflow and underflow protection, so we don't need safe math libraries anymore. And here we have imports. We are importing OpenZappelin libraries, which are industry standard battle tested contracts. First of all, we are importing the reentrancy guard, which basically protects functions from reentrancy attacks. Okay, another one is ownable, which basically adds ownership logic for contracts, so the only owner can perform certain actions like an authority. And lastly, we are importing counters, provides an easy way to handle auto incrementing numbers safely. We'll be using these for listing IDs. And now we are basically here declaring our marketplace contract. It inherits from reentrancy guard and ownable contracts. Here in ownable, we are passing message.sender. This makes the deployer of the contract the initial owner. Okay, and now after that, we will declare all of the variables, starting from the state variables. Here we are, declaring the listing IDs variable with the help of counters.counter, which will use the counter library functions, and the listing IDs will be our internal counter for generating unique listing IDs. After that, we have, specified structs. We have two main data structures. First of all, we have the listing. In the listing, we have provided ID, which is unique listing ID, the seller data type, who listed the item basically, and followed by title, description, image hash, price, is it active or inactive, and lastly we have got the timestamp when it was created. Okay, and another struct that is purchase, we have the listing ID, buyer, seller, and price, and lastly timestamp. It's pretty straightforward. Then we have declared a tree of the mappings. These mappings are very important because, these mappings are pretty important to map our data. First of all, we have listings, which basically maps listing ID to listing detail, followed by purchases, which maps listing ID to purchase details, and lastly, user listings, which maps user address to array of listing IDs they created. And then we have, declared some variables for platform fees, such as platform fee and fee denominator. Okay, lastly, we have the events, which basically pops out whenever the function executes. These are set to specific functions. Whenever that function executes, these events pops out. Okay, now we have the modifiers. Modifiers are basically functions which are required in order to execute another function. These are basically the requirements. First of all, we have the listing exists. If the listing exists, then only another function will be able to execute. Here, we just have a require statement, which checks if the listing does exist. If not, it throws listing does not exist. We also have another modifier, only seller, which takes parameter listing ID, and it basically ensures only the seller of that listing can cancel the listing. Okay, now we have gone to the main functionalities. First of all, we have the create listing function, which basically take 4 of parameters: title, description, image hash, and price. And it is an external type of function. That means it can be called through external sources. We have set the request statement so that title cannot be empty and price must be greater than 0. Thereafter, we are incrementing the listing ID by .increment function of the counters library, followed by creating a new listing ID and then specifying that to our listing structure with the mapping functionality. We are specifying the ID, seller, title, description, image hash, price, active, and timestamp in here, and we are just pushing that data into the new listing ID, followed by emitting the event which we created earlier. Okay, now we have another function known as purchase listing. What it will do is it will make user able to purchase that listing. So we are just making this function payables. Users should be able to buy out the listing. Okay, this is a non-reentrant function so that no attacks can be made to this function. Okay, we are also using the modifier listing exist here so that the listing properly exists. Okay, in this function, first of all, we are declaring the listing struct, and we have a couple of require functionalities, and then we are making the listing.active false, because if the listing is purchased, then it cannot be active. Then we have the platform fees, seller amount, followed by listing.seller.transfer, the seller amount, which just transfer the amount the seller's sent. Okay, we just transfer the amount to the seller, and hence the function will be executed and the data will be fulfilled to the defined mappings, followed by emission of the event. And lastly, we have a function for the cancel listing, which basically cancels the listing. It's pretty straightforward. Okay, now we have some view functions that basically fetches the storage from the smart contract. These functions doesn't require gas. These are not return functions. These are just view functions which are just calling the smart contract and getting data from that. At last, we have withdraw platform fees. This is only on a function. That means the authority only can use this function. If I'm the authority, I can only withdraw the platform fees from the smart contract. And at very last, we have the get total listing function, which return listings which we created. So now that we know each and every functionality, structures, variables of these smart contracts, now what we need to do is compile it. We can just press compile or Control S. We will get all the built in. Okay, so now that we know each and every functionality, structures, it will automatically import the dependencies that it needs and make artifacts. Now we need to go to the deploy tab. Here we will connect it with the injected provider, that will be the MetaMask. Open my MetaMask, and I have got some TRBTC from the faucet. So if you don't have the network you can just go to here over the chain list, and if we want some TRBTC, we can just go to faucet.rootstock.io, and we can just simply paste our address and just get test RBTC. Okay, I already have them, so I'll just go to the smart contract deployment section. Here we can see our marketplace.sol smart contract and rootstock testnet. I'll just hit compile, and once it compiles, that means we can successfully deploy the contract too. Now I'll just press the deploy button. It will trigger a transaction in my MetaMask wallet. I'll just wait for it. As you can see, MetaMask wallet has popped up, and we'll just hit confirm. Once the transaction is confirmed, contract will be successfully deployed onto the chain. Okay, we'll just wait for it. As we can see, our transaction has successfully been confirmed and our marketplace has been deployed. As we go downwards, we can see the marketplace and our deployed contracts. We have got all the functions which we defined in the marketplace, the call functions, the payable function, and the normal functions. Congrats, guys. We have deployed our contract to the testnet of Rootstock blockchain. Congrats, now we will, deep dive into the front end part of our dApp. So for it, I have dropped the link of the GitHub repository for the Next.js application. You can just go ahead and, clone the repository from there. I'll just go ahead and, cd from my local system. Now we will, deep dive into the front end part of our dApp. So for it, I have dropped the link of the GitHub repository for the Next.js application. You can just go ahead. I'll just open the command prompt in here. We will just go into the RBTC backed marketplace, and I'll just, open up it with cursor. And we can just, go ahead and run npm install to install all of the dependencies which we need in this tutorial in order to, perform interaction with the blockchain. We'll need ethos.js, voice connection, mask, and various others for animations and other cool things. Once the installation of all of the packages is complete, we can, move forward and run the command npm run dev. It will just pop up our website on, have a look at our marketplace. It's a pretty minimalistic and simple UI. So we have got our create option to create new listing, and we can just simply connect our wallet with this connect wallet button. Once I press this button, the MetaMask will pop up. Just put on my password. We'll just continue with the MetaMask, and here we can see the previous listing. Okay, these are some cool listings though. Now, let me just go ahead quickly and show you all of the code. Now, first of all, we have our Next.js application here, the public folder, smart contracts folder, and store. Okay, now for establishing a secure Web3 connection in our dApp, we need to provide a Web3 provider. So in hooks, we have written a Web3 provider, use web3.js. I'll just walk you through this very fast. In here, first of all, we are importing the ethos and defining the rootstock testnet properties, the chain ID, chain name, RPC URL, and native currency, that is the RBTC. Okay, we are defining the block explorer URL. After that, we are just making a null context named as Web3 context. And then we are defining our Web3 provider, in which we are, creating provider, signer, account, chain ID, and we have a connect wallet function. This is the main function which will, pop up our wallet. And here, if window.ethereum exists, we can go ahead. If not, we are just alerting the user that please install MetaMask or some wallet. After that, we are, requiring the window.ethereum.request to request the accounts. If account exists, that's good. If not, if it is on the right network, it will proceed. If not, it will, it will push this function that is switch to rootstock testnet. What this function does, it basically switch our wallet to the rootstock testnet, that properties which we defined earlier. And yeah, that's just simple. We have a disconnect wallet function here. After that, which we have a use effect, which basically tracks the changes made it in the accounts. Okay, now that's our Web3 context provider. At last, we are just exporting it. Now, we need to use this Web3 provider in our main layout in order to, get it accessible across all of our files. That's why we are putting it in our layout.tsx file and wrapping it under the children component. Now, another main thing is we have the use marketplace.js, which is our main component to interact with the smart contract which we built earlier. Here, I have written the smart contract address and the marketplace ABI that we can get from the Solidity compiler of Remix. And here we are defining the use marketplace hook. In here also, we are getting provider, contract, listing, and loading status. It's just checking for the provider and signer. If they exist, it will move forward and establish a connection with the marketplace contract. We can establish a connection using ethos library by new ethers.contract and passing the marketplace address, AVI, and a valid signer. After that, we are just setting the contract to marketplace contract. And in here, we have another function that is create listing. This function will be a asynchronous function and the title, description, image, hash, and price as its parameter. It will be used to create the product listing which we have connected through the form. What it does, it just passes the fees and calls the contract function of create listing, and if it goes through, it shows the status to success and shows the product that is listed. If not, it alerts the error. Thereafter, we have the purchase listing function. It is the function for user through which it can easily purchase the listing. It's just again calling the contract function, the purchase listing function, and passing the subsequent value of the price, that is the product's price. Okay, you're just waiting for the transaction to be success. If it goes through, it's well done. If not, it's just causing an error, right? Now we have fetch active listings function. This function will be used in listing cards so that we can style the listing cards and showcase them in the grid. Okay, so what it actually does, it's just calling the contact.get active listings and then formatting listings so that we can get it in the adequate type. Thereafter, we have the fetch users listing. What it does is it fetches the listing for the current connected account in the same manner as above by just calling the contact.get user listings function. It just take user address as the parameter. Okay, at last we are just running the function with use effect. Okay, that's what this whole useMarketplace.js hook is doing. Now, in order to pair this useMarketplace.js in components in the listing card, we are using the purchase listing from useMarketplace. It's just passing out those parameters and the transaction status, the loading status, and doing those all the catch and try functions to calculate the error. In the listing grid, what we are doing is we are just fetching all the active listings through our use marketplace hook. So it automatically fetches the listing and showcases it in the grid. Thereafter, in header.tsx, it's very important part because it has the connect wallet component in it. What we are doing here is here we have the button through which the user is capable of connecting the wallet. On click is causing this connect wallet feature, which is basically importing it from the use web3 hook, which we defined earlier. So that's what it's happening in this whole dApp. I guess all of you understand that. Now we can just go ahead and interact with the dApp. We can just go ahead and choose the file. Let's say I want to sell this game board. Amazing. Let's say define its price to 0.000 6 RBTC. We'll just create listing and it will pop up my MetaMask to confirm the transaction. I'll just hit confirm and we can check up on the status through here, the contract interaction. It takes around 30 seconds to proceed the transaction on the Rootstock blockchain. As we can see, our transaction is confirmed, and when I'll just refresh this and we are able to see our newly listed product. Okay, that's too cool, right? And we are able to. Now, let me show you some Rootstock specific features that make this platform a way too cool. Instead of ETH, you're paying gas with RBTC. The gas price here is typically around 60 million Wei, which is way cheaper than Ethereum mainnet during peak times. What would cost you $50 in gas on Ethereum in the Rootstock blockchain? That's going to be too cheap. That's a game changer for user adoption. For advanced use cases, we can directly integrate the Bitcoin bridge directly. This lets you verify when users have actually logged BTC before they receive the RBTC. You can query the bridge API to check the status of BTC deposits, which is perfect for applications that needs to verify the real use case of the Bitcoin transactions. Rootstock supports all major standards for Web3 event patterns. You can listen for marketplace events in real time, which makes a much better user experience. When someone purchases an item, your UI can update very immediately without requiring a page refresh. It's like getting too fast interfaces. So what you can actually build with this architecture, the possibilities are pretty exciting. Obviously, decentralized e-commerce is a big one. Imagine Amazon, but with Bitcoin security, everything, without any intermediaries. P2P Bitcoin trading platforms are another natural fit. You can build sophisticated trading interfaces with escrow services, all backed by the Bitcoin security. Also, you can build something innovative like token-gated communities using BTC as collateral, Want access to an exclusive community? Lock some Bitcoin and leave the community, get your Bitcoin back. And then there's DeFi platforms like lending, yield farming, insurance products. All of these become more interesting when they are backed by the Bitcoin security rather than, more volatile tokens. Let me share some tips I have learned from building on Rootstock. Even though gas is cheaper, it's still a good practice to optimize, pack your scripts efficiently, use events for off-chain indexing, and patch multiple calls when possible. Always handle the common Web3 errors gracefully. Insufficient funds, users rejection, network issues. Your users will thank you for clear error messages. It will be so, empowerment for the UX. Test locally first, then on Rootstock testnet. The beauty is that all your existing EVM testing tools work perfectly fine. Hard hat test, waffle, whatever you are comfortable with, just go ahead and do it. And don't forget to verify your contracts on Rootstock Explorer. It makes debugging and community trust much easier. Alright, that's it. You now have a complete Bitcoin-backed marketplace running on Rootstock. Everything we built today is available in the GitHub repository I have linked below. Complete smart contract code, React frontend, deployment scripts, and a detailed README with setup instructions. I've also included some bonus material such as architecture diagrams, configuration guides, and even some UX wireframes if you want to look forward to it. The cool thing about what we built is that it's just not a tutorial project. This is production-ready code that you can extend, customize, and deploy for real users. So here's my challenge for you. Take this code, make it your own, and build something amazing, whether it's a marketplace, a trading platform, or something completely different. If this helped you out, smash that like button, subscribe for more Web3 tutorials, and let me know in comments what you're planning to build next with this amazing Rootstock block. Until next time, keep building.